Hello. Hello. My name is Charlie Arbuso. I'm going to be a chemistry teacher. This is the weirdest first day. This is the weirdest thing in the world to Zoom and not actually see you in the room. But I'm glad you're here, whatever that really means. I actually am glad you're going to be with me mentally. Some of you are going to come to school sometimes. Some of you are not going to come to school sometimes, and we'll just do the Zoom thing. But I'm so glad you're here. I love my job. This is a challenge for me. I'm actually better in person than I am on TV. TV makes me look a little older. I'm only 27, but my hair looks so gray. I don't know what to say about that. Before we get started, I need to just show you a couple of things that you need to have. You need to have this, the Regents Chemistry Measurement notes. All right, I gave this to you. You're going to need this. I'll show you most of it on the slides so you can follow along. If you don't have it, you should go get it. Put a pause button, right? It's a pause. You're also going to need this. This is called the reference tables. There's a whole lot of tables in here. We're going to get through all of them. Honestly, it's a little overwhelming because there's so many of them. But we're going to do them one at a time. And you need to have that. You should have a pencil also. Pens are good. I have a whole bunch of pens, all different colors. But you're going to make mistakes. Mistakes are part of learning, and that's okay. So get a pencil. Hit pause if you have to. I'll wait for you. I'll be here, right? I'll be right here. All right, this is the room. This is the back of the room. I'm up against the window. I haven't figured out where to zoom from. I don't want it to be too dark. When this is over, I'll look at it. Maybe the next Zoom, I'll move over into the middle of the room. But I feel pretty good by the open window, get some fresh air from the outside. Took my mask off because I'm in the room alone. This is my classroom, 262. This will be your classroom. In public, I wear a mask all the time, of course, and I hope you do also. And when you come to school, I hope you wear a mask because that's what the school rule is, and we don't want to get involved in any problems. And we also obviously have to stay safe. So here we go. We're going to talk about measurement. Now, chemistry is a really, really big topic. Honestly, it's too big to cover in one school year. And with a year like this, we're going to have to make some trimmings here and there. And I haven't decided where to trim it yet, but this is really the basic stuff, like how to measure. And you can't learn chemistry unless you know how to measure it. So we're going to do everything at the beginning, all the beginning stuff, the measurement, the atomic theory, how atoms work, what atoms are, what molecules are, and chemical reactions. A lot of that stuff is going to definitely be done completely. Later in the year, we might have to trim a little bit of the organic chem out or maybe a little nuclear chem out. But for now, we're going to do everything. So here we go. The notes have all of the notes. We're going to open it up to the first page, and it says day one. Let's start. So I have to share my screen now, and I'll be ready to do that in just a second. The measurement class notes, share. Here we go. And we're going to go with the, I can't see the slideshow from the beginning. It's a little bit bright facing this. Come on, from the beginning. There we go. Let me move myself right out of the way into the corner. You don't really want to see me anyway. Okay, this is the slide that I start every single year with. And I'll say it again just so you know that this is an important first line. Welcome to class. My name is Charlie Arbuso, and I will be your chemistry teacher, okay? My name is hard to spell. My name is hard to say. Do your best. Arbuso, just like it's spelled, even though it's not spelled that way. Okay, the objective. What the heck are we doing here today? Well, today's objective is to describe the synthesis of dihydrogen monoxide. You write that down. There's a spot right there next to number one, a big space. Objective, describing the synthesis of dihydrogen monoxide. Now, I know you don't really know what that means, okay? Keep writing. I know you don't know what that means, right? Today's going to be fun. We're going to do real chemistry that you, honestly, yeah, you probably won't really get too much of this. It's okay. We're going to come back to this particular lesson later in the year, and you're going to be like, oh, yeah, I remember that whole first day business. Okay, so here we go. Synthesis of dihydrogen monoxide. The next slide. I say, what's the chemical formula for water? Now, first of all, before we even go any further, I say water, you say water, water with an ER at the end. I don't know why you talk that way. I don't talk that way. You'll get used to how I talk, and that's just the way it is. Unfortunately, I talk like most people in New York State, and you talk like you're from Vestal or somewhere like Vestal. So, chemical formula for water. Yell out the answer. Everybody probably knows this, right? It's not very hard. On the next slide, we're going to see in a little bit, we're going to be able to see the answers, all right? The chemical formula for water is H2O. You know that. Big H, capital H, little 2, that's down, a little subscript 2, and then capital O. Now, the H, what does that stand for? Uh-oh. Let's get out this old reference table. And from the back, we're going to open it up 2 pages, and we'll fold it back. And we get to my favorite thing in chemistry, the periodic table of the elements. Element number 1, H. Now, you might not know what that is. Maybe you do. If we turn the page to the next page, right at the very top, H. I don't know if you can see that too well. The first element, H, is hydrogen. Happens to be element number 1. It's not the best element. It's a good element, but it's not the best element. It happens to be number 1. Now, the O, I always tease that it stands for Oprah. I don't even know if you guys know who Oprah is anymore, but it doesn't stand for Oprah anymore, right? O stands for element number 8 by my thumb, 8. And if you look that up on table S, you'll see that element 8 stands for oxygen. Oxygen. Take a deep breath. Okay, the little 2 in the middle. What does that little 2 mean? Capital H, little 2, capital O. What does that little 2 mean? That means there's going to be 2 hydrogens. Why is there no little 1 by the oxygen? How come it's not H2O1, right? That would make sense. Okay, there's only 1 oxygen atom, and if we write a capital O, there it is. We don't have to say it again. H2O means there's hydrogen twice, oxygen once. You don't have to say once again. If there's a capital O, that means it's there. So we never write the number 1 in a chemical formula. That's because chemistry is the number 1 class, okay? It is the best class. We're number 1. You heard that expression? We're number 1. Okay. Hydrogen and oxygen are both special elements, and you couldn't possibly have known this because they do not exist as atoms when they're found in nature, when they're pure, okay? They're weird little elements or weird little atoms. Atoms make up elements. A whole lot of atoms is an element. Hydrogen is an element. Oxygen is an element. They exist diatomically, right? The best element, I told you there was a best element, number 80. You can look that up. That's my favorite element, number 80. I'm going to open my seltzer now. I drink a lot of this stuff. Wegmans seltzer. Best stuff in the world. There's so much chemistry in this can, but we'll talk about that another time. Number 80 is the best element. Most elements exist when they're pure as atoms, but it happens to be 7 of them. Oxygen and hydrogen are both part of that 7. They only exist as pairs. So they're called diatomic. It's a little more complicated than I want to get into. They're a little bit afraid and anxious, and so they pair up and hold hands together. So the formulas for hydrogen and oxygen really are H2 and O2, right? O2, you probably heard of H2. These elements, when they're pure, right, they exist as H2. I had a balloon. It got away. We'll get to it again. It flew away. It's filled up with hydrogen gas. It's actually filled up with H2 molecules, not H atoms. The H atoms are a little too anxious. They're a little too reactive, and they bond together. Oh, the lights went out. Let me see if I can get them to come back on. What a crazy world we live in. Lights on. If I don't move around enough, the lights go off. It thinks that I'm not here anymore. So these elements exist as pairs. So when they're pure, They're pairs. Now, in a few minutes, we're going to synthesize dihydrogen monoxide. We're going to take H2 and O2, and we're going to combine them chemically to make water. All right, how cool is that? We're going to make water. Now, there's a certain amount of water in the universe. There's a certain amount of water in the world. There's a certain amount of water in Vestal. There's even water in my seltzer, which I'm going to drink some. Wegman seltzer is the best. Now there's a little more water in me. There is a lot of water. And some of it's in the gas form as steam. Some of it's liquid, and there's some ice and some freezes. There's a lot of water. But actually, if you think about it, you could measure how much water there is. We're going to make more water in a little while. I am. You're going to have to watch today. We're going to actually make more water. So if you were keeping track, if you could keep track, there's a certain amount of water right now, and in a little while, there's going to be more water in the universe because I'm going to combine hydrogen and oxygen together. Now, to write a balanced chemical equation, tricky business. You don't know how to do that yet. I'm just going to show you. You're going to have to copy some of this. Now, the skeleton is like, how do we begin? We have to write stuff correctly. We have to write the formula for hydrogen correctly, which is H2. It's diatomic. Plus sign means we're going to add it to something. O2, what are we adding it to? O2. Hydrogen and oxygen. We're adding them or combining them together. We're going to synthesize them into water. The arrow means a chemical reaction happens. So we have H2 plus O2. Chemical reaction happens and we get water. The arrow means a reactor it forms into. It's a chemical reaction. So we're going to start with two things, hydrogen and oxygen. We're going to end with something different, something that has different properties, something that is structurally different, built different, and is different and acts different. A chemical reaction, you start with some stuff and you get different stuff with different properties. This is a really important reaction, and we're going to do it. I'm going to do it in a little while. It's very exciting too, very exciting. Now, it should be pretty obvious that we're missing one atom of oxygen on the right side, right? We started out with O2 and in H2O, it's H2O1, but we don't write the one, H2O. Where the heck did that other oxygen go? That's bad. That's really bad. You cannot lose your atoms, right? You can never gain atoms. You can't lose atoms. The arrow is kind of like an equal sign. This becomes that. This is that in a different form, right? If you make a peanut butter and jelly sandwich, you start with some peanut butter, you start with some jelly, you make and some bread, three things you start with, and then you make a peanut butter and jelly sandwich and you can eat it. Now, when it's all together, it's a peanut butter jelly sandwich. But when it's not made, there's peanut butter in a jar, jelly in a jar, and bread. It's different, but you can't lose it. Like when you take some of this peanut butter and some of this jelly and some of this bread, you put it on a scale, it should weigh the same amount, and it does, of course. Where is that other oxygen? The problem is it's really right there. You just don't see it. The balanced chemical equation is not in front of us yet. This is called the skeleton. In order to balance a chemical equation, you have to start with the skeleton. You have to write everything correctly, the formula for hydrogen, the formula for oxygen, and actually the formula for water. And then you have to balance it. We're going to get to that in a minute. The law of conservation of matter is something that you have to write down now, number 11, and you're going to have to memorize this. You probably already heard of it. Okay? Matter cannot be created or destroyed in a chemical reaction or in a physical change. Now, a physical change is like melting or freezing or vaporizing or the reverse, right? Condensing. There you go. Can't lose stuff. So this skeleton is a good start, but it's not balanced. So it's not done. We have to be able to balance it. Now, honestly, again, I'm going to remind you, you don't have any idea how to do any of this stuff right now. If you feel a little anxious, good. Don't worry. You're feeling perfect. This is what I want you to feel. This class is going to move right along. You're going to have to figure out what's going on. And, you know, don't worry. This is good. You're in a good spot. Now, we're going to talk our way through balancing this. Now, I haven't done this since last year. I got to figure out how to write on my Zoom. I got to find my pen and I got to pick a color. Let's see, colors. I'm going to go with red. Here we go. And let me move this silly thing out of the way because I can't see it. You know what? I can't see it. Let's see. I'll move it to the bottom. I'm going to talk your way through this balanced chemical equation business. Nice and slow. This is how you do. You talk to yourself. In the beginning, there's two hydrogens. And look here at the end. The beginning of the reaction, we have two hydrogens. At the end of the reaction, we have two hydrogens. This is not a gang sign. This is balancing equations. 2 and 2. So far, so good. This is easy. All right. The problem is right here. Look at this. 2 oxygens, 1 oxygen. These are not the same. In chemistry, it's always got to be the same. So this is what we're going to do. We're going to talk our way through it. You're not going to understand. It's okay. We're going to get to the big explosion coming soon. We're going to have a really big explosion. It's going to be a lot of fun. Let me talk you through this. In the beginning, we have 2 hydrogens. And in the product here, we have 2 hydrogens. That's good. And in the beginning, the reactant side, we have 2 oxygens. We only have 1. Now, I could put a little 2 here, right? Oh, look at that. Now it's 2 oxygens. This, of course, is not water anymore. This is something else called hydrogen peroxide. So can't really do that, right? This is why you got to use a pencil. I don't even know how to erase. I forget. In order to get 2 oxygens we have in the front to the back, I can't make just one water. Water only has 1 oxygen. Who says I have to make just 1? You know what? Look at this. I'm going to put a 2 right here. This stuff is really starting to, there we go. 2. Look at that. So now this 2 means right here. See this 2? That one right there. That 2 means, hey, I got 2 waters. I have H2O and another H2O. That's 2 O's. So I got 2 O's in the front and 2 O's in the back. How cool is that? It's pretty cool, but right, what about the hydrogens now? How many hydrogens do I have in the front? 2 hydrogens. How many hydrogens do I have in the back? I have H2O and another H2O. That would be 4. That's not good either. I can't change this front little 2. I can't make that a 4 because the formula is H2. But look what I can do. Put a 2 right here. Look at that. How cool is that? It takes 2 hydrogens and 1 oxygen to make 2 waters. Now it's balanced. There's 4 hydrogens in the front. Look, count them. 2 H2s. That's 4 hydrogen. There's 4 hydrogens in the back. There's 2 oxygens in the front. And look, O doubled. Now it's balanced. This is a balanced chemical equation. And the best way to balance chemical equations is to start at the beginning and to talk to yourself like I did. How many I got over here? How many I got over there? How do I fix it? You can never change the formulas. Once you have the skeleton, you write stuff correctly. H2 plus O2 makes H2O. Those are the 3 formulas here. You can't change the formulas. You can't make it H2O2, right? That's not water anymore. All right, so let's see where we are now. Next slide. I'm going to X out of this here, and I'm going to go up. How do I erase all this stuff I haven't done in a long time? Annotate. Clear. Clear all my drawings. There we go. And now I'll X out. Sorry, kids. All right, this is the balanced chemical equation. And you can think your way through this. I talked about all this already. Yep, we're going to turn the page. We're only on the second page of notes. Whoa, what's going on here? My can that my seltzer is in is made up of element number 13. Might as well look. It's right over here. See it? Al. Al is a fine element, right? Airplanes are made out of it. My seltzer cans are made out of it. But some people think 13 is unlucky. And as a science teacher, I like to make fun of people who don't believe in science in a polite way. I don't make fun of people directly, but in my heart and in my mind, they say, oh my goodness, those people just don't get it. So we never have a number 13 if I can help it in my class, right? I tease that I don't like aluminum because aluminum is the 13th element, but really I do like aluminum. I drink a lot of seltzer. A lot of my stuff on my bicycle derailleur is made of aluminum. I love my bicycle. Aluminum's pretty handy. It's a nice, good metal. And 13 is not really an unlucky number, but make believe, and it's just for fun. Here we go. Now, there's going to be in this class 16 different kinds of chemical reactions. It's someday, May or June, I'll give you a piece of paper and I'll say, list all 16 chemical reactions and give me a balanced chemical equation for each of them, right? That'll be a hard day. There's a lot. It's all right. This one's called synthesis. Synthesis is the first one. Some people call it combining or combination reaction. Synthesis is the word that we're going to use. This is when two or more reactants form into one product. You add them together. You combine them. In this case, 2 hydrogens and 1 oxygen makes 2 waters. Reactants become products. What you start with becomes something different. The reactants have properties. The products have different properties. They're different things. It's not a mixture. That's something else we'll get to. We're not mixing them. We're chemically combining them. They form something new. All right. In this reaction, the two reactants are hydrogen and oxygen, and the product has a scientific name of water, or dihydrogen monoxide. Now, dihydrogen monoxide is kind of cool. You can use it. It's a perfectly legitimate name. 2 hydrogens with 1 oxygen. The hydrogen comes first, the oxygen comes second. That's the rule. We'll get to the rules another day. But you can always call it water or water, because it is water. You can call it water. You can call it ice. You can call it steam, but it's H2O. All right, there you go. Now, I'm going to do a demo in a second. It's going to be a very loud bang. I've never done this through Zoom. I have no idea how loud it's going to be. You might honestly want to turn your volume down in a second. I'll give you a little warm up before I actually do it. But I have a balloon filled with hydrogen. It's blue. I'm going to tape it to the table and I'm going to adjust my camera so that you can see it. All right? And what I'm going to do is I'm going to light it. I have a candle on a long stick, the meter stick, because we use metrics. I didn't use the inch sign. I used the centimeter and millimeter side. I'm going to light it up on fire. The heat is going to melt a little bit of the rubber balloon. That's a physical change. It's going to melt it. And then the hydrogen gas is going to be exposed to the fire. And that's going to shake those little molecules of hydrogen up like mad. And they're going to start to react with oxygen that's in the air. Take a deep breath. Oxygen. Can't smell it, can't taste it, but you got to have it all the time. Do you know why you have 2 holes in your nose? Do you have 2 holes in your nose? I have 2 holes in my nose because oxygen is O2. And when you take a deep breath, 1 oxygen goes in over here and 1 oxygen, no, that's not true. I do have 2 holes in my nose. There's a lot of oxygen in the air. The air is about 17% oxygen, which is plenty for this explosion. And the heat is going to kickstart this reaction and then kaboom. It's a very, very explosive reaction. Some reactions give off energy and some reactions absorb energy. There's 2 different kinds of thermochemistry there. The one we're going to do today gives off a lot of energy. We call that exothermic. Kaboom! And if we do an endothermic reaction, that makes things colder. It sucks energy in from the environment. But this one's going to release a lot of energy. So we'll get to that in a minute. But the balanced thermochemical. Now remember we did the skeleton, and now we did the balanced chemical equation. This is going to be called the balanced thermochemical reaction. We actually add in the energy. So you can write this down too. Same balanced chemical equation. Let me get the lights again. I'm going to have to deal with this. There we go. 2H2G, that G in that little parenthesis there, that's called the phase symbol. Hydrogen's in a gas phase. Oxygen from the air is a gas. And the water, because it's going to be such a violent heat giving off explosion, most of the water formed is going to be in the gas phase. Some of it might condense. You might see a drop or 2, but probably not through Zoom. Okay? So we're going to have hydrogen gas and oxygen gas makes water gas plus energy. Now, in reality, every single chemical reaction requires energy to be added. I mean, my balloon's been hanging out. I don't know if you can see it up there. It's on the ceiling now. because hydrogen's lighter than air, like helium. So it floats up. That balloon can stay here all week. It's not going to explode. It's perfectly safe. But if you spark it, give it some energy, then you get a good reaction, as long as there's oxygen, right? If you were in a room that, well, I couldn't be in the room, but if the room was completely filled with carbon dioxide, no oxygen, they pumped in carbon dioxide and tried to light that up, it wouldn't work because the hydrogen needs oxygen in order to combine. And even though carbon dioxide, that's another chemical formula you'll probably know, CO2. Even though there's oxygen in carbon dioxide, it's not acting like oxygen because it's acting like carbon dioxide. It's a new substance that has its own properties. So if the room was filled with just carbon dioxide and that balloon, we couldn't light the balloon up. But there's plenty of oxygen here. So thermochemically, we're going to have energy come out. Now, we always add energy at the beginning, and we always get energy out, no matter what kind of reaction. It's just a matter of where is there more. I'm only going to add a little energy. I'm going to get a lot of energy out. Sometimes you got to add a lot of energy, and only a little energy comes out, and that means most of the energy is with the reactants. That would be, you're adding more energy than you're getting. That would be endothermic. This, completely, wildly exothermic. Okay. Oh, so here we go. I guess this means I got to do this. So I'm going to get up. I'm going to shut some screens so it gets darker in here so you can actually see the explosion better. I'm going to make this bigger so I can see what's going on. I'm going to move this. It's a little hard to do. How do I make it bigger? Oh my gosh. There we go. I need to be able to see where we are so that I can, this whole Zoom thing, I promise I'm going to get better. I used to do a lot of Zooms from my house, but now that I'm doing them in school, I guess it's as big as it's going to get. Now that I'm doing them in school, I got to get used to this different machine. And that balloon got away. But here I come. Now, not all balloons are made the same. This balloon looks like it's made with helium, right? Because you're used to helium. Helium will float. Kids like helium balloons. I got a really good story about helium balloon that I'm going to tell you later in the year. I'm going to put some extra goggles on here. Safety is very important, right? Wear your mask, wear your goggles. All right. Because it's so loud, I actually have to take this tissue. I would teach you to cover your ears like this. Now, I don't think you have to do this on the Zoom because it's going to be loud. I don't know how loud it's going to be on Zoom. You better be prepared. But I can't do that. My hands are going to be busy. So I'm going to stick a little bit of tissue in my ears because it's going to be loud and I don't want to go deaf. Usually I do this 4 times. I'm going to go turn the lights off too so it gets even darker. Usually when we're in school, I make one of the students stand up and I ask them their name. Hey, what's your name? All right, Joe, get up and shut the lights. See this? It's a little clicker lighter. Makes a little flame. See that flame? This is a chemical reaction too. It's called combustion, right? When you take the liquid in here that sprays into a very misty gas, it's a hydrocarbon combines with oxygen in the air. It actually makes carbon dioxide and water, but it's in the gas. You can't see that because it's so hot and a lot of heat comes out. This is exothermic. This is different. It's a second chemical reaction in one day. Holy cow, you're getting a big education. So I'm going to light this candle. Also combustion. Now what we're going to see when I blow this balloon up, it's going to be explosion, but it's not combustion, right? It may look a little like combustion. I'm going to shut this window a little better. It may look like combustion because it's exploding and you're not You're not good at chemistry yet. This is combustion. The clicker light is combustion. My gasoline in my car. I have a punch buggy convertible. I love my car. Combustion. This explosion. Super fast. Exothermic synthesis. All right, here we go. You watch it. I don't know how loud this is going to be, so you might want to turn your volume down. For real, going to be loud. Holy smokes. That was cool. Actually, it wasn't cool. It was crazy hot. See this little piece of broken balloon? I always give this to somebody. Hey, what's your name? I say, what's your name? Because I got to get to know people. I don't know anybody yet. This is for you. Take this home and show your family during dinner. Do you know what this is called? You know what I say? You know what this is called? And nobody knows. A piece of broken balloon. They don't know. Blue rubber. This is called a smithereen. I blew that balloon into smithereens. How cool is that? All right. I love chem. I hope you can tell that because that's true. Here we go. Tonight for homework, immediately, read the first day handout. It's 2 pages, typewritten. It's long, all about this class. You need to read it. Your parents and guardians need to look at it too. Fill in your student information form. It's a handout. Basically, it's your name and how to contact you and tell me a couple of sentences about you. I want those back. Give them back to me soon. I keep them in a black folder. I've had the same black folder. This is my 15th or 16th year here at Vestal. Keep it on my dining room table. I'm going to call your families. I'm going to tell them nice things about you and how well you're doing. And hopefully I get to meet a lot of you. Please, pencils. Got to have a calculator. I use a really cheap calculator because those fancy calculators are over my head. Most of what we're going to do is really just simple math, but we got big numbers and you want a calculator. I like loose leaf. I don't care what you do though, but spiral notebooks are terrible because if you write on something and I'm going to collect it, what a mess, okay? Also, get psyched. This is going to be a great class. I love it. I don't know you yet, but professionally speaking, I'm going to love you too. And you are going to love chemistry, all right? This little explosion is just the beginning. Endless fun. And some of it's going to be hard. This is going to be the hardest class you ever took, but you're smart, right? They wouldn't have put you in chemistry if you couldn't handle it. You can handle it. I can help you. Now, for real, every single year, there's problems. Somebody gets appendicitis, somebody breaks their ankle, somebody's out of school, somebody's got to go on vacation with their parents. They don't want to go. They don't want to miss chemistry, but they got to go away to, I don't know, France for a week. How fun is that? I'd love to go to France. Maybe not now, but in general. And somehow or another, I will help you catch up, right? Some of you will struggle a little, and I will help you catch up. Some of you at the beginning are going to fight me, right? You're going to say, no, this is too hard. I'm not doing all this work. I don't care. Chemistry's so stupid. Who cares? I have heard every little story you might ever imagine you're going to tell me. It's okay. I'll be patient. I'll keep working on you. Usually, I pull everybody through. Right? Hardly anybody ever fails this class. They have to work really, really hard to fail this class, but it's going to be very hard. It's not going to be easy to get 100. Not even going to be easy to get an 85, right? There's a lot. You're going to have to do a lot. And honestly, look at us. You're there. Where are you? I don't even know where you are, right? Zoom is not going to be as wonderful, but if you watch these videos and follow the notes and you read the basics, right? That's the other big pack I gave you. The basics is like the textbook. I have 3 textbooks under my laptop here to hold this up. That's about all they're good for. The chemistry textbooks that we have are written by people who know a lot of chemistry, but they hate teenagers. And if you read that book, you're going to hate chemistry. Trust me. I rewrote everything you need to know in stuff called the basics. The measurement basics is everything you basically need to know about measurement. Everything that was good in that book, written in a way that you might appreciate a little more. Now, some of you are going to say, the basics, they stink, they're boring, I don't want to read them. You better read them, okay? Read them. You're big. Do your job, right? You're way better than the textbook, right? The textbooks, all I use them for is lift, right? 3 books lifts this laptop up so my neck doesn't hurt. All right. In all that other paperwork is my cell phone number, my website, arbuiso.com. Everything important is on that website. My cell phone number is on that website. If you have any stress, right? You have chemistry stress. You have math stress. You have life stress, call me up. I'll answer the phone. Try not to call too late and never call too early. All right. I mean, on school days, you know, I got to get up by 6:45, but try not to wake me up. If it's ever an emergency, call me anytime. If I hear the phone, I'll get up. All right. I don't sleep with the phone in the same room, but if you need help, I'm your man. All right. We're going to have a great year. This is difficult, but you know what? Governor Cuomo said a long time ago when this all started, he goes, you know what? No matter how bad this is, this quarantine, this everything, this worry, everything, he says, your life is going to be really, really long. There's a little part of it. Maybe it's even this part. I don't know how little it is compared to how big your life is, but this is temporary. You still have to learn chemistry, and I'm going to help you do that. All right? Over and out. You keep watching these videos, you're going to learn a lot. I'll see you soon. But I don't know how to turn this off, so now you're stuck with me. Let's see. Turn off the video. More. Stop recording. See ya.